Okay, today we're doing Module 4, Lesson 7, moving right along. And yesterday we used pictures to help us find a fraction of a whole number, right? Remember that? Today we're using something else, tape diagrams, to multiply fractions by whole numbers, or whole numbers by fractions. Same thing, right? For multiplication, can I commute the different parts, the different factors? Is there a commutative property of multiplication? Is there? Yeah, so can I say if I multiply a whole number by a fraction, is that the same thing as multiplying a fraction by the same whole number? Yeah, very good. Is 1 times 2 the same thing as 2 times 1? How about 3 times 4? Is that the same thing as 4 times 3?
Yeah.
So can I commute the factors?
Yeah.
Thank you. Looking at this top diagram in black, what kind of equations could it show? I'm going to tell you right now that this is exactly half. This is half of the whole thing, okay? So what equations could this tape diagram show if I'm trying to find this part right here? Turjo?
10 divided by 2.
It could be 10 divided by 2. Do you guys agree?
Mm-hmm.
Could it show anything else? Ani?
5 is 5.
Do I know that that's 5? Not by looking at the tape diagram. I'd have to do 10 divided by 2 to get the 5. What fraction of the whole is this? So is this 1/2 of 10?
Yeah.
Oh, okay, interesting. What about for this blue one? We again have a piece of tape, but this time the entire piece of tape is 8, and it's split into how many equal size portions? 4. So if we're trying to find one of those sections, what equations could this tape diagram show? It could be 8 divided by what? Everyone? 4. Or what fraction of the whole is this one piece? It's 1/4 of 8. Very good. If I'm trying to find what 3/5 of 35 are, remember that the denominator always tells us what our units are going to be, right? So if my denominator is 5, how many units will I need? How many? 5. So I'm going to draw a piece of tape, or I drew a piece of tape right here, and I split it, and the whole tape was 35, right? I'm going to split it into 5 equal sections. Now this time, am I trying to find 1/5?
No.
I'm trying to find how many fifths?
3.
3, right? So the numerator tells me how many of those sections I'm trying to find. So I can show that by drawing this bracket with the question mark. Go ahead and set up your tape diagram. Then we can see that the entire tape diagram is divided into how many units?
5.
5 units, and it's 35, right? 5 units is 35. So how can I find out how much 1 unit is? Well, I have to divide 35 by 5 to find out how much 1 unit is. Do you guys agree? So what's 35? And do you guys see how I wrote 35 over 5? Is that the same thing as 35 divided by 5? Yeah. What is 35 divided by 5?
7.
So therefore, 1 unit, this 1 unit is worth how much? 7. But how many units are we trying to find? 3, because our numerator says 3/5. So that one's 7, that one's 7, and that one's 7. So I could do 7 plus 7 plus 7, or I could do 7 times 3, which is 21. And so therefore, we can see that 3/5 of 35 is how much? Is how much? 21. Very good. This is an example of how we use tape diagrams to help us find a fraction of a whole number. Don't forget that we need to put this part here too to make it complete, the units part. Wait a second. This is showing us how to find, using a tape diagram, a fraction of a whole number. But if we look at our learning goal, it says to use tape diagrams to multiply fractions by a whole number. Well, I have something exciting to share with you. In math, when you have a fraction multiplied by a whole number, you can think of the multiplication sign as the word of. So 2/3 times 18, you can think in your head it's the exact same thing as 2/3 of 18. This is super important. I want everyone to write in their notebook right now that the multiplication sign means of. So looking at the denominator of the fraction, what is my denominator? 3. So it tells you how many units you will need. How many units will we need? 3. Okay, so let's draw our piece of tape. This time our entire piece of tape is going to be how big? 18. That's what this number always tells you, is how big your entire piece of tape is, the whole number. Okay? The denominator tells you need to split it into how many equal sections? 3. Okay. The numerator tells you how many of those units we are looking for. How many of those units are we looking for? 2. And you can show that by drawing the brackets and the question mark. You can also, if you want, lightly shade in the amount of units that we're looking for, if that helps you. Okay? Then we need to write the stuff about the units. How many units do we have all together in this 18? 3, right? 1, 2, 3. So we write 3 units equals 18. Okay, then we first need to find out how much 1 unit will be. Okay, so the whole thing is 18, and I just want to find out how much is in 1 unit. What do I need to do to 18? Divide it by 3. So it's going to be 18 divided by 3. Another way to write 18 divided by 3, of course, is 18 over 3. And what is 18 divided by 3? 6. Okay, but the question's not asking us to find 1/3 of 18. It's asking us to find what? 2/3. So I need to do, how many units am I trying to find? 2 units. So then we write here 2 units equals 6 times 2, or 6 plus 6, right, which is 12. So therefore, 2/3 of 18, or 2/3 times 18, is equal to what? 12. Very good. So in this example, we're trying to find out what the entire whole number is. Okay? We don't know what the whole number is, but we do know that 2/3 of it is 8. So I can divide it into thirds, and I can show that 2 of those thirds is 8. Do you guys agree that this reflects the situation? Okay. Now, how many units do we know? Well, I know that 2 units is how much? 8, right? Because from here to here is 8, and that's 2 units. So how can I find out what 1 unit is? I have to do 8 divided by, which is? Okay, so if I know that 1 unit, this is 4, another unit is 4, and this unit is also 4, does that help me find the entire number? How many units would I need to find the number? 3, so I can write 3 units equals 4 times 3, which is 12. So the number must be 12.